This is Gateway to Science. Well, you may say this is only a gate to an athletic field, and you are right. But did you know that this is also a place where you can learn about physics? You can understand physics and geometry, too, through athletic activities. So, this is Gateway to Science, Sports and Games, and I am your host, Kathy DeLay Hogan. Hi, I'm Kathy DeLay Hogan. I want to welcome you to Gateway to Science, Sports and Games. And this is going to be about all that and much more, science, sports, and games. And now I would like to introduce you to my husband, Frank Hogan, who is the co-host on this show and the producer.
Thank you, Catherine, for the introduction. There were some nice shots of Quincy Stadium there. It was enjoyable. This is a learning program, and might as well say that as far as science goes, my favorite science is Star Wars and science fiction, but I am learning from you. I realized that a stadium was the original measurements that they used when they started measuring the distance between cities, and eventually that's how they measured the circumference of the world, was through stadiums. But what would you like to tell people about science and physics?
About learning science?
About learning, yeah.
Well, actually, you don't have to be a whiz at science to learn it. I never actually studied science, or physics rather, when I was in high school, but over the years I acquired an interest in it, and I wanted to know more about it. It was only when I got the idea of learning physics through sports and games that I started to study it, and I took a class.
Mm-hmm. Besides the classes, you did a lot of studying and you had a mentor, but basically, how did you do with your classes?
Well, I did well because I was really motivated. I wanted to do well. I wanted to learn. I really did want to learn. I really wanted to get it. But there were some things that I still didn't really and truly get. But over the last several years, because I keep working on it, I start putting pieces together more and more. So it's an ongoing thing for me.
Mm-hmm. And you find things are falling into space the way they should do, into place.
Into place, they do. There's also a possibility in this show that I could be giving people some wrong information based on what my understanding of something is at this particular point. And I will try to avoid doing that by, first of all, sticking to the things that I feel most comfortable with. And secondly, inviting somebody who is watching the program, if they are more knowledgeable, to get in touch with me and educate me, and maybe come on and educate others about it. Mm-hmm. And also, if there is something that I don't really know, I might just gloss over it. I won't pretend that I understand it. Won't focus on that part of it.
Yeah. I was just wondering, we do learn by mistakes, don't we? Let me just have a little look at here. Okay. Oh, now, do you expect people to put some time into this? It's physics, and it's a little daunting to me. And what are you doing? Are you asking people to devote some time to it, or just learn the language? Some people might not put all the time into it that I do, because I have a special reason for doing so. What I'm trying to do is to learn it in such a way that I can take and put things in a very whole picture. I really think that learning holistically is the way to learn, rather than just learning one little piece of the puzzle, which you might understand beautifully, but if you can't explain how it relates to something over here, I don't think you have a true grasp of the whole picture. So I think that's very important. And there's lots of different ways that you can go about doing this. Now, do you have a lesson for us today?
Not a lesson per se, but I do have something planned. And because the Winter Olympics is underway right now, I thought that would be a nice place to start.
Yeah.
And through NBCLearn.com and the National Science Foundation, 360, science360.gov, they have put together some wonderful videos on the science, the physics of the winter sports. They're great. And I've selected a couple of them to work on.
So this is what's next. We're going to see these
Yes.
little. Oh, could we see them, Andrew?
We're not quite ready to
We're
start.
not quite ready. Oh,
Right.
okay. I'm
What I-
anxious to see them. I've been enjoying the Winter Olympics tremendously.
I have been too.
Just feeling a little sad about Shaun White, but
I
let's
know,
not
I
distract
know.
from what we're doing here. Okay.
The first video that we're going to look at today is called Figuring Out Figure Skating. Now, this video goes into several scientific points, including how to get height and how to get speed in a jump. But what I'm going to focus on today is two things. It's the speeding up and the slowing down and how that's done. Also, angular momentum. When the figure skater is spinning around, she uses her arms to determine speed or slowing down. She brings her arms in close to her center of axis. And this minimizes contact, reduces drag, and she goes fast. When she wants to slow down, she uses her arms in the other way, and she puts the arms out. And this brings her arms away from the center of axis and introduces drag, and that's how she slows down.
So she spins like this on the axis, and you
Yeah,
put your arms
just like
out.
the axis
you
of the Earth.
Put your arms out like a plane puts its flaps out when it wants to slow down. So that's
Right.
basically speeding
Yeah,
up.
bringing in drag.
You cut out the drag.
Cut out the drag, yeah.
Okay, that's simple enough.
Yeah,
And now I know some physics.
yeah, that's actually a good point. A very good way to really get this stuff. And when I was talking about learning it in a holistic way, it means seeing how the same principle is applied in other contexts. Then you really start to understand it. And so that was good what you just brought in there.
I've enjoyed some of these home lessons that we've had, and I have learned several things. But one of the things used to fascinate me as a child. They say the world spins round 360 degrees. I used to wonder why we were up here, like this. This is me on top of the world, and then the world spins and you fall off. What is it that keeps us on? Gravity.
Gravity. Right.
And that was the lesson you taught me about
force,
gravity.
a force that attracts you to it.
So I'm almost a scientist. I know it's gravity that keeps me in location on the world.
Yeah, and that gravity that people generally understand as it relates to the Earth and the Moon, they don't truly understand it when it relates to everyday activities. And that's the big purpose of this program, is to bring that kind of thing in.
So in future programs, you'll help us to understand how they relate to everyday
yeah.
life.
Everyday life, not just sports, not just games, but everyday activities. Right.
And the other thing you were trying to teach me, which was the language of physics related to sport. Will we go into that a little later?
We're going to go into that later.
Good.
We already understand the physical forces within our body. We feel it, we know what to do, we know how to react, but giving it a name makes such a difference when you really start getting a concept, an idea. Yeah. And when you have an idea, then you can see it again in other applications.
But the body already understands.
I feel like the body understands it. I think skateboarders are a beautiful example of people who are masters of physics.
Yeah. Well, you see, I think you do. When you see a hole, you jump over it, you don't step into it. So, that's part of physics. Or the wind's blowing, you lower your head and it dissipates it around it like a nice new car with wind.
Right. Well, There's one other thing that I want to point out before we get into this video. It's about momentum, and specifically it's about angular momentum, because momentum normally goes in a straight line. But in the case of these figure skaters, they're going in a circle. And a circle has 360 degrees. And so the skater is constantly going at an angle all the way around. So it's called angular momentum.
So within the circle, there's all these like little straight lines, but they're so short, when you look at them as one, it becomes a circle.
I think you could probably describe it like that. But other people who are watching this who know a lot more than you and I do will probably pick up on that.
About the sport or the angular momentum.
The angle part of it, yeah.
Well, I
Anyways.
think you could give him a run for the money. You've done a lot of studying, and
No.
you had a very good mentor.
Huh?
You had a very good
I
mentor
do.
as well.
Oh, yeah. Dick Leonard is a great mentor. All right, so I told you a little bit about angular momentum. So what we're going to do here is demonstrate in a swivel chair the way the figure skater is going to do this and do that. So
I'm
are
the
you the
guinea pig.
volunteer?
The guinea pig.
Yeah.
Put it more that way, okay? So, hey, maybe I should do this, but go USA in case I win.
Okay, that's a good idea.
Can't put my glasses on. So, welcome to the Winter Olympics in Quincy. This is going to be the spinning chair. What's it? Momentum?
Yeah, swivel chair.
Still with momentum.
Yeah, well, what we're going to demonstrate particularly is the speeding up when you have your arms in, because your arms are close to your central axis, and it minimizes drag. And then when you want to do the opposite, when you slow down, you can put your arms out.
Okay.
Okay.
Are you ready?
Do you need a push, or can you?
No, I'm
okay.
fine.
Okay.
Yep.
Take her away.
Take it.
I think you did need a push. Arms out.
Boy, I can feel the drag on it, seriously.
Yeah, put your arms in. Let me do it again because you got off to a rocky start.
Okay.
And what I'll do is I'll spin you the other way so you won't get too dizzy going
Okay.
in one direction. Okay. 1, 2, 3, go.
Oh,
Now, arms out. Slowing.
I feel the air when I put the
Arms
down.
in.
This is-
I don't know. I mean, the chair itself is slowing down.
Yeah, well,
It's a little bit-
can I ask you one thing?
Yeah.
Oh, I took my mic off. Oh dear. My mic off. Wasn't very scientific, was it? My mic off.
Anyway, well, I think we're ready to show the video. Figuring out.
Wait, before we go to the video, what medal did I earn for that?
You didn't.
No medal? Golliston, you should have brought one of your medals for me. Oh dear.
So here,
I apologize about taking the mic off when I was up there, but it was fun.
here is figuring out figure skating.
Now we'll
Oh,
see
these
the
are
back.
yours.
Every 4 years, we watch the stakes for Olympic figure skaters get higher as they try to increase rotation in the air with their triple axels and quadruple toe loops. How do they do that? It's a scientific principle that we asked Olympic hopeful Rachel Flatt and Deborah King, a sports scientist funded by the National Science Foundation, to help explain.